Today we are going to solve Cambridge paper O levels year May June 2022 paper 2 variant 1. It is a theory paper and question number 1. Figure 1.1 show a model of a human arm. The rubber band represents the muscle of the part of the arm XY. A mass is suspended from XY as shown in figure 1.2. The weight of the section XY is negligible and the model is at rest. The weight of this XY rod is going to be negligible. Why it is going to be negligible? Because if it consists, we consider the mass of this body, it will produce some movement in the body. Okay. In part A, what is asked? State two ways in which the dimension of the rubber band changes as the mass added to section XY. When we add the mass to the section XY, our rubber band will going to be stretched. Our rubber band will going to be stretched. So its length going to be increased. And as we know that the rubber band stretches, its width or the surface area, or we can say that area of the rubber band become less. So width decreases and length increases. Its width decreases and its length increases. Okay, one mark for the increase of the width and one mark is increase in the length. Okay, the second one, state the form of energy stored in a stretched rubber band. We know that everything that is stretched have elastic potential energy. Have elastic potential energy. Okay, the question B, part 1, state the principle of movement. What is movement? Movement is a force applied on a body and body move in a circle. So for the movement, principle of movement is clockwise movement and anti-clockwise movement is equal if the body is in equilibrium. One mark is for the clockwise movement and anti-clockwise movement is equal, and the other mark is for that you write that the body is in equilibrium. If you just write the clockwise movement is equal to anti-clockwise movement, you will be marked as 1 mark. Your question will be marked as 1 mark. You will not given the second mark. You have to write clockwise movement and anti-clockwise movement is equal if the body is in equilibrium. Question number 2. Explain why the force that the rubber band exerts on section XY is larger than the weight. Okay, let's see why this force is larger. From here, we can see that the perpendicular distance of mass from the pivot point is 18 centimeter and rubber band from the pivot point is only 2 centimeter. So if the movement arm is less, so the force should be high. So clockwise movement will be equal to anti-clockwise movement. Due to smaller distance, the movement of movement arm we have to apply more force. Due to smaller distance of the movement arm, we have to apply more force. Okay, question number 3. The mass suspended from section XY in figure 1.2 has a weight of 4 Newton. This weight has weight of 4 Newton. What will be the force of the rubber band? What will be the force of the rubber band? Okay, we know that clockwise movement is equal to anti-clockwise movement, and from here the pivot point is your x, and this mass will move this body in this direction, so it is clockwise movement. So clockwise is 4 Newton multiplied by 18 centimeter, 16 centimeter this one, and 2 centimeter this one, so the total is 18 centimeter. So 4 multiplied by 18 is the clockwise movement, and your rubber band will move the body in this direction, so it is anti-clockwise, and we have to calculate the force by this, and F multiply by 2, F multiply by 2, so F will become 4 into 18 divided by 2, 2 1 2 2 2 into 18, 36 Newton. So your force will be equal to 36 Newton. Explain how your answer to B3 is different if the weight of section XY is not negligible. As we have discussed earlier, that if there is weight of that rod, if the weight of that rod, then there should be a movement due to this rod. So you have to apply more force. You have to apply more force. The weight of rod XY also apply clockwise movement to overcome it. The rubber band has to apply more force, has to apply more force. Okay, here the question 1 ends. Now we are going toward the question number 2. Figure 2.1 shows a wind turbine. The wind blows directly toward the turbine and the speed is 12 meters per second. In 1 second, 60 kg of air passes, mass is 60 kg, of the air passes through the circular area swept out of the blades. Calculate the kinetic energy. We know that kinetic energy is equal to 1 by 2 times mv square, which be equal to 1 by 2 times 6000 multiplied by 12 square, which will be equal to 3000 multiplied by 144. 12 square is equal to 144. So it will become 432,000 joules. So the kinetic energy will be equal to 432,000 joules. Question number B. A wind turbine release no carbon dioxide into the atmosphere while generating electricity, compared with a coal-fired power station. This is an advantage of this wind turbine, that it does not produce any carbon dioxide. State one reason why it is important to reduce the amount of carbon dioxide. We know that due to carbon dioxide, global warming increases. So, for reducing carbon dioxide, we will reduce the global warming. To reduce the global warming. Okay. So just one advantage of using a coal-fired power station compared with wind turbine. So we know that wind is not always blowing. So wind is not always blowing. That's why our wind turbine will not work continuously. For continuous energy, we need continuous wind. That is not possible. What other options we could have? We could write it also as for the production of power station we need less we can say that less area, less land needed for coal power station. You can write any one of these. For continuous energy we need continuous wind, that is not possible. Less land needed for the coal power station. Question number 2 part C. A coal fired power station releases 0.9 kg of carbon dioxide in air. 0.96 kg of carbon dioxide in air when it generates 1 kilowatt hour of electricity. Define 1 kilowatt. Okay, what is 1 kilowatt? 1 kilowatt is the unit of energy. 1 kilowatt hour is the unit of energy. So we can define as energy utilized by device or anything device of power 1 kilowatt in 60 minutes or 1 hour. Okay, the energy utilized by a device of power 1 kilowatt in 60 minutes or 1 hour. Okay, calculate the mass of carbon dioxide. Calculate the mass of carbon dioxide saved when the wind turbine has a power output of 22,000 kilowatt and operate 12 hours. So, for 1 kilowatt hour, 1 kilowatt hour, 0.96 kg of carbon dioxide releases. Now 2000 kilowatt and 12 hours. So 2000 multiplied by 12 kilowatt hour. When we multiply these two, we get the energy, and X will be our amount of carbon dioxide produced. So by the ratio method, X will be equal to 0.96 multiplied by 2000 and multiplied by 12. It will be equal to 23040 kg. So this amount of carbon dioxide is not released if we use our wind turbines, not using coal-fired power station. Wind energy is a form of renewable energy. Part D. State the name of one other form of renewable energy. So for the renewable energy we know that hydroelectric energy. Number 2, our uh, solar energy due to tides, biomass, waves. These are some examples of renewable energy. Question number 3. Define latent heat of fusion. It is the amount of energy. It is the amount of energy to change the state of matter from solid to liquid, keeping the temperature constant. by keeping the temperature constant. It is the amount of energy needed to convert or needed to change the state of matter from solid to liquid without changing its temperature or keeping the temperature constant. Question number 3 part B. A sample of metal P at 100 degrees centigrade is heated steadily until its temperature reaches 400 degrees centigrade from 100 to 400. The melting point of metal is 250 degrees centigrade. On figure 3.1, sketch a graph to show how the temperature of the metal changes with time. So first of all, our temperature starts from 100 and reaches to 250, and it will going to be a straight line at 250 until our whole metal melts. After melting, it will reach to 400 like this. So it starts from 100, reaches 250, show a straight line due to melting point. When it completely melts, the temperature starts to increase and reaches 400 degree centigrade. A sample of different metal Q has a higher latent heat of fusion, has a higher or greater latent heat of fusion of sample P. P and Q are metal with same melting point. They both have the same melting point, but the other sample has greater latent heat of fusion. So it need more energy to convert from solid to liquid. Okay, P and Q are the metal of the same melting point and have same heat capacity. The experiment is repeated with the sample Q. This sample is supplied with the same amount of energy per second as it's supplied to the sample of P. Explain how the graph of temperature against time for Q different from in figure B1. So, how it is going to change? You will write it as it has greater latent heat of fusion, as it has greater latent heat of fusion. It will take more time to convert from solid to liquid. So due to this, we get more longer line at 250 degrees centigrade, 250 degrees centigrade, due to its due to because it take more energy, because it take more energy to melt. So what is going to happen? It is going to happen like this. We need the line will become more long at this portion. Two parallel rays of light, one red and one blue, enter a glass prism. Figure 4.1 show both rays of the light before they enter the prism. The blue ray is also shown incident on a different sides of the prism after passing through the prism. The ray of blue light strikes the left side of the prism at an angle equal to its critical angle. Okay, this is our critical angle over here, left side. On figure 4.1, mark and label the angle of incidence and the angle of refraction are for the blue light. So for the blue light, this is going to be our angle of incidence and this is going to be our angle of refraction. Okay. On figure 4.1, continue the path of blue light after it strikes the left side of the prism. As angle of incidence is critical angle, it will bend at 90 degree. Bend at 90 degree. Okay ji. Question number 3. The refractive index of glass for red light is smaller than the refractive index for blue light. Its refractive index is higher for the red light than the refractive index for the blue light. On figure 4.1, draw the path of the red light as it travels in the prism and after it strikes the left arm of the prism. So as the refractive index is smaller, so it will refract less. Refract less mean the line will be something like this, not as much bended as our below line, this line. So it will not going to refract, or it is not going to be at the angle of our angle of incidence is not going to be critical angle, so it will be refracted outside like this one. So we are going to get 2 marks, one for the inner side which will show that the refraction is less, and the outside it will go outside from the prism, not at 90 degree because it is not striking at the critical angle. State what is meant by critical angle. So this is asked in many papers before this one. So angle of incidence, the angle of incidence for which the sorry I write wrong spelling, for which angle of refraction is 90 degree. Okay, the refractive index of glass for blue light is 1.5. Calculate the critical angle for the blue light in glass, showing your working. To find the critical angle, we are going to use the general formula n1 by n2 is equal to sine r over sine I. n1 is glass, which is equal to 1.5, and n2 is air, so it will be 1. Sine r, sine r will going to be sine 90 because its angle of refraction is 90 degree for critical angle, and we have to find the critical angle mean incidence angle like sine c. So it will be equal to 1.5 is equal to 1 over sine c, and c sine c will be equal to 1 over 1.5, and c will be equal to sine inverse of 1 over 1.5, and it will be equal to 41.8 degree. 41.8 degree. Your critical angle will be equal to 41.8 degree. Or you can use the general formula n is equal to 1 over sine c, which is mostly used for the finding of the critical angle, where n is the refractive index of glass, which is equal to 1.5, and c is the critical angle. Question number 5. Figure 5.1 show a simple DC motor used in a toy car. So terminal A and B are connected to the battery and the motor rotates. On figure 5.1, add label inside the boxes to identify the parts of the motor indicated. So what are the parts? What are these two parts? And what is this one? So we know that these two parts A and B are called carbon brushes. Carbon brushes. And this one is called as commutator. Commutator, or this is also called as split rings. You can write either split rings or you can write as commutator. These two are the permanent magnets, and this one is your coil. State what happened to the rotation of the coil when the number of the turns are increased. As we know that the number of turns are increased, the rotational speed also increases. So rotational speed increases. rotational speed increases. The magnetic field between the poles of the magnet is reversed. When we reverse the direction of the magnetic field, our motor will rotate with the same speed. But what happened to its rotation? Its rotation will going to be reversed. Its rotation is going to be reversed. Question number 5, part C. The power supply to the motor is switched on and off at a steady rate. Figure 5.2 shows how the speed of a toy car varies with time as a result of the power supply being switched on and off. Describe the motion of the toy car. Its speed increases, then it start moving with the its speed increases and it start moving with the steady speed over here, and then its speed start decreasing, and then speed start increasing and move with steady speed start decreasing, then increasing, then move with speed, and it go on like this. So how can we write it? We are going to write it as speed of the car increases, speed of car increases, then it move with steady speed, steady or constant speed, then its speed decreases, then before coming to rest, because our body is not, our speed is not zero at any time. Before it come to rest, speed start increasing, and this process continue. This process continue or repeat. So many spelling mistakes. Speed constant increases start. Okay. Now, number 2. The voltage supplied to the motor is switched on and off for the longer period of time and off for a longer period of time at a steady rate. Suggest what happened to the motor now, or the speed of the car toy. So from this we can say that it will going to be the maximum speed same, steady for a long period of time, going to be decrease for a long period or come to rest. We can say that it may come to rest, or then again speed increases, steady speed for a longer time, and it going to be the car stops, or the car come to rest. Steady speed for the longer time, and car may become may come to rest, or you can say it stop, or it stops if we switch off it for the longer time. Steady speed will be going to be increased, steady speed for the longer time, and car may come to rest, or it stops between every switch on and off. Question number 6. A light dependent resistance LDR is used to sense the amount of light in a room. Figure 6.1 shows part of a circuit used. The LDR is not shown. Complete figure 6.1 by drawing the circuit symbol for an LDR between point P and Q. So how we are going to draw the LDR? You are going to draw a box like the resistor or these three arrows showing that the light is incident on it. Okay. Part 2, explain how the voltmeter reading changes as the amount of the light falling on the LDR increases. Okay, the amount of reading on the voltmeter over here and the amount of light. If the amount of light is going to increase, the resistance is going to decrease. The resistance of the LDR decreases as the amount of light increases. The resistance of LDR decreases. If this resistance decreases, more potential will drop across the fixed resistance because the potential is divided between these two. One potential is over here and one potential is over there, and the battery potential is divided in both of these. If this resistance decreases, so its potential is going to decrease. So the potential across LDR decreases and potential across resistance increases. So voltmeter reading, increases. So okay, as the potential of the LDR decreases, the potential across the resistance increases, so the voltmeter reading increases. CREASES. Okay. Part B. Figure 6.2 shows part of a circuit containing three resistors. Current across the first resistor is not given, which is 6 ohm resistor. Current across the 4 ohm resistor is 2.4 volt, and the current across the 5 volt resistance is also not given. The current in the 4 ohm resistor is 2 ampere. Show that the current in 5 ohm resistor is 1.9 volt. As we know that the potential across these 2 points will be same. So the potential across the 4 ohm resistance will be equal to V is equal to IR, and V is equal to 2.4 multiplied by 4. 2.4 multiplied by 4, which would be equal to 9.6. So as we know that the potential across this point across this resistor or this resistance will be same. So V is equal to IR. Your V is 9.6. Current we don't know, and the resistance is 5. 5 divided at that point, then current will be is equal to 1.92 ampere. 1.92 ampere. And in part 2, calculate the potential difference between point X and Y. Now we have to find the total potential. As I know that the potential across this point is 9.6. If I know current at this point, I can find its potential. What will be the current over here? We know that current divide in parallel circuit. So current in 4 ohm resistor is 2.4 and current in 5 ohm resistor is 1.9, which is also founded by us. So by adding these two, our current across 6 ohm resistor will be equal to 1.9 plus 2.4, which will be equal to 4.3, which will be equal to 4.3. Now the potential V is equal to IR. V is equal to 4.3 multiplied by resistance 6, and potential will be equal to 25.8. So the total potential will be 25.8 plus 9.6, and it will be equal to 35.4 watts. It will be equal to 35.4 watts. Question number 7, figure 7.1, show a toy helicopter. It can hover and travel through the air. A student flies the toy helicopter on a journey A to B, then B to C, and then C to D. On figure 7.2 is a scale diagram of the path of the helicopter viewed from above. Determine the total distance traveled by the helicopter. What we have to find? Total distance. So from A to B it is 10 meters, from B to C it is 35, and from C to D it is 40. So by adding all these, 40, 70, 80, 85 meters. So the total distance traveled by the body is 85 meters. The toy helicopter makes the journey in 40 seconds. The total time taken from A to D is 40 seconds. Calculate its average speed. Average speed is equal to total distance divided by total time. So it will be equal to 85 divided by 40, which will be equal to 2.1 meter per second. State the difference between distance and displacement. We know that distance is a scalar quantity while displacement is a vector quantity. Distance is a scalar quantity while the displacement is a vector quantity. Determine the scale used to construct figure 7.2 and complete the sentence. 1 centimeter on the diagram represents 1 centimeter on the diagram represent on the path. Okay, from A to B we are going to calculate the distance or the length of the path shown. It will be by using scale. You are going to measure it by using scale, and this 10 meter will be equal to 2 centimeter. From A to B by using scale you will find out it will be 2 centimeter. So 1 centimeter will be equal to 5 meter. The scale diagram is 1:5. So I am going to represent 1 centimeter on the diagram represent 5 meter on the path. 5 meter on the path. Okay. Using figure 7.2, determine the size of the displacement D. Determine the size of the displacement D from point A. Show your working. Displacement. What is displacement? Displacement is the shorter distance between 2 points, and it will be like this, and I will making it look like a triangle. This is your 35, this is 25, because sorry, not 25, this is 30. Why 30? I will tell you. This distance is 10, so from here to here it will be 30. 40 minus 10. I have to find the hypotenuse of this right angle triangle, and we know that hypotenuse square is equal to perpendicular square plus base square. So hypotenuse square is equal to 30 square plus 35 square, and our hypotenuse or our displacement will be equal to under root 30 square plus 35 square. For removal of this square, we are taking the square root and it will be equal to 46 meter. Determine the angle between north and the direction of displacement of point D from point A. From point A. Now we are going to calculate this angle. We are going to calculate this angle. You can use D or you can use the formula. It's up to you. First of all, if I take this angle theta, this will be my base, this will be my hypotenuse, and it will be my perpendicular. And from the formula, tan theta is equal to perpendicular by base, and theta will be equal to tan inverse of perpendicular by base, which will be equal to tan inverse of perpendicular 30 and base 35. Perpendicular is 30 and base is 35. So what is the value? By using calculator, shift tan 30 divided by 35 and it will be equal to approximately 40.6. I am writing over here 40.6. You can write over here 40.6 or you can subtract it from 360. By subtracting it from 360, I will get 360 minus 40.6 equal to 319.3 degree. You can write either 40.6 or 319.3 degree. It's up to you. State what is meant by velocity. We know that velocity is displacement divided by time. Displacement divided by time. Okay, question number 7, part B and part number 6. Another toy helicopter flies directly from point A to point D in 40 seconds. Explain why the magnitude of the velocity of this toy helicopter is smaller than the answer in A2. What is the answer in A2? A2 is 2.1 meter per second and it will be equal to 85 divided by 40. So when we are going to find the velocity, as we know that displacement is small, the value of displacement is small and time is same, so the answer of velocity or the value of velocity is also small. When the toy helicopter hovers at D, its motor fails and it falls. It reaches the terminal velocity as it falls. Explain in terms of the force and acceleration what happened as the helicopter falls and reaches terminal velocity. Okay, at start its velocity increases from 0 because it is at rest, and due to increase in velocity, the force or we can say that the force due to air resistance also increases and body start to decelerate and reaches the terminal velocity when weight become equal to air resistance acting on the body and and acceleration become zero at that point. Question number 8. Figure 8.1 shows a water manometer. When the water manometer is connected to a sealed container of gas and the tap is open, the water level changes as shown in figure 8.2. Define pressure. So pressure is force per unit area. Pressure is defined as force per unit area. Part B, question 1. Explain why the water level are same on both sides of manometer 8.1. In figure 8.1, at both sides, the pressure exerted is equal to the atmospheric pressure because on both sides the pressure is same equal to atmospheric pressure. Explain why the water level changes when the gas tap is opened with the manometer connected as in figure 8.2. In this figure, when we open the gas tap, the gas will apply pressure to the liquid, and so the sealed container gas applied pressure, and due to large pressure the water level rises over here. Water level rises over here. So how we are going to write it? Gas apply more pressure than the atmospheric pressure, so the water level increases or change. Explain the water level stop changing at level shown in 8.2. Why after this the water level does not change? Okay, you can write because both sides will have equal pressure, both sides pressure become equal, pressure become equal, pressure of gas is equal to atmospheric pressure plus pressure due to liquid, pressure due to liquid. Okay. Part C. The water in the manometer has a density of 1000 kg per meter cube. Atmospheric pressure is 1 into 10 raised to power 5 Pascal and the gravitational field strength G is 10 meter per second square. Calculate the pressure of gas inside the sealed container. Give your answer to 3 significant figures. Now we know that by this formula atmospheric pressure. Pressure of gas will be equal to atmospheric pressure, which is 1 into 10 raised to power 5 plus pressure of liquid. The pressure of liquid will be equal to rho g h. So 1 into 10 raised to power 5 plus rho mean density, which is equal to 1000. Value of g is 10, and height. The difference between the height will be equal to 70 minus 30, which will be equal to 40 centimeter. By converting into meter, we will have 0.4, and it will be equal to 1 into 10 raised to power 5 mean 5 zeros plus 0.4 multiplied by 10 multiplied by 1000, which will be equal to 4000. So we have 104,000 pascals. We would have 104,000 pascal, or you can write it as 104 kilopascals. The temperature of the gas inside the sealed container increases. Using ideal gas molecule, explain why the water level changes. As the temperature increases, the kinetic energy of the molecules also increases. So they collide more frequently and with larger force with the liquid and apply more pressure. Okay. As the temperature increases, the kinetic energy of the molecules also increases. So they collide more frequently and with larger force with the liquid and apply more pressure. Question 7 is question 7 or 8? Just a minute. It's question number 8. Part E. This manometer is not suitable for the measurement of the gas of 2.5 into 10 raised to power 5 pascals. Explain why. As we know that for the pressure of 104 kilopascals, it reaches to 70 centimeter. So if the pressure increases to 2.5, the water will come out from this manometer. So it is not suitable because the manometer, the length of the manometer is small. The water will come out of the manometer for this pressure because the pressure is much greater than atmospheric pressure. State one change to this manometer that allow it to measure a gas pressure of 2.5 into 10 raised by 5 pascal in a normal school laboratory. In normal school laboratory, we do not have a large manometer or with high length manometer. So we can use a high dense liquid. So the high dense liquid will apply more pressure and it will not go. The water will not go out of the, or the liquid will not go out of the manometer by using a high dense liquid. Question number 9. Table 9.1 show detail of 7 different nuclides: hydrogen 2, hydrogen 3, francium 223, iridium. And in part A, hydrogen 2 and hydrogen 3 are isotopes of the element hydrogen. Define isotopes. What are isotopes? Isotopes of an element have same atomic number, or you can say proton number, but different mass number, or you can say nucleon number. Nucleon number. The basic difference between the isotope is the number of neutron. They have different number of neutron. The equation for the decay of phosphorus 32, P32, as it emits a beta particle is shown. Explain whether the equation shows that Q is another isotope of phosphorus. Q is not the chemical symbol for the atom. Q is not the chemical symbol of the atom form. Is this Q is the isotope of phosphorus P? No. For isotopes, they must have same proton number, because phosphorus has 15 protons and Q has 16 protons. So they are not isotopes. Q is another element. They are not isotopes because they have different atomic numbers. One of the source in table 9.1 is used in medical procedure to detect unusual bone structure. It is injected into the patient, and the radiation emitted is detected outside the body. State which source in table 9.1 is more suitable for this. Okay. Alpha and beta are not going to be used for this purpose. We are going to use gamma for this purpose, because alpha and beta are not capable of coming outside of the body, or we are not going to detect a good quantity of radiations emitted outside. Okay, so we are going to use gamma. Now we have gamma. For the gamma radiations, we have two elements. One is iridium and one is technetium. So we know that for this purpose we have to use the radiation emitter particle which have a low half-life or less half-life. So we are going to use technetium 99, which will emit gamma radiation for only 6 hours. In 6 hours we can detect, or we can detect the fracture in the bones, and it is enough time for the detection of the gamma particle or for the detection of the problem. So we are going to use technetium 99. Technetium 99. Explain two reasons for your choice. Now you have to give two reasons why you have used this technetium 99. As I have told you, because it has less half-life. And the second one, sorry, half-life, spelling are wrong, HALF, half-life. And the second option is that it can pass easily from the tissues, or you can say tissues or muscles of the body, and can be detected. Part C. Radon is one natural source of background radiation. Some causes of background radiation are man-made, for example, X-rays. State one another natural source of background radiation. So from background radiation we know that it comes from the food, it comes from the sun, it comes from cosmic rays, and also the rocks and buildings, because many elements decay down and emit back radiation. State 1, other man-made source. Other man-made source is your nuclear power plants. Nuclear power plants. They also emit background radiations. State 1, harmful effect of the background radiation. They damage human tissues. You can also write it as, just a minute, damage human tissues. You can say that cause cancer, or we can say that cause mutation, in the body of human being. Okay, one fusion reaction that occur is hydrogen plus hydrogen make helium plus X. Complete the equation to show the missing proton and nucleon number. Okay, 1 plus 1 is equal to 2, so it will be 0. 2 plus 3 is equal to 5, so it is 4 plus 1, so 1 and 0. Deduce the name of the particle X, so it is 1 and 0. Its atomic mass is 1 and atomic number is 0, so it will be neutron, because neutron has the atomic mass 1 and atomic number 0. Suggest where this fusion reaction take place. We know that fusion reaction take place at sun, or where temperature is very high. Temperature is very high in different stars. Compare the properties of alpha particle and beta particles in terms of their ability to penetrate through material. So I am going to write answers one by one. Alpha particles are less penetrating than beta particles. They can be stopped by a thin sheet of paper. So, ability to penetrate, alpha particles are less penetrating than beta particles. They can be stopped by a thin sheet of paper. Or ionizing effect. We know that alpha particles has more ionizing power than beta particles due to more charge, because alpha particle is +2 and beta particle is just -1. Deflection in magnetic field. Both are deflected in magnetic field. Both are deflected in magnetic field, but in opposite direction. Both are deflected in magnetic field, but in opposite direction. If one is deflected upward, then other will be deflected downward. And we can know that alpha particle deflect less than alpha particle deflect less. Please like the video and subscribe the channel. Thank you.